Hello, my name is Sadeep. I'm a customer success engineer at Quix. Today we are going to deploy a Simulink model to Quix because being able to work with MATLAB and Simulink with Quix means that you can develop model-based applications such as digital twins with Quix far more easily, quickly, and cheaply. For this demonstration, I'm going to be using .NET to interact with MATLAB, but we also support Python. Here I have a Simulink model of an internal combustion engine developed by MathWorks that models engine speed as a function of throttle angle. Now here at Quix we support MATLAB, Simulink and all their toolboxes, which means this feature is in no way limited to automotive applications. We're going to save this model as a .slx file. Then we're going to create a very simple MATLAB function that bootstraps a Simulink model by setting the input parameters and running the simulation. Next, all we need to do is upload these assets to Quix. If we head over to Quix, under code samples, you can see that we have created code templates for MATLAB and Simulink that you can deploy and run with minimal changes. If I go to Simulink and if I create a project, this creates a Git repository that contains a folder called MATLAB, which is where we have uploaded our Simulink model and the MATLAB functions required to run the Simulink model. And then we simply call the MATLAB function called engine using input parameters, that is throttle angle and time. Once we are ready, we click on deploy, select the number of CPU cores and memory that is required for our simulation and click deploy. If I head to pipeline view, you can see that I have deployed a Simulink service based on the project that I just showed you and it's running. Here the MATLAB engine has started and it's listening for an input stream. If I go back to the pipeline, we have a service called Simulink input that's going to stream throttle angles in real time. Now the Simulink input is essentially simulating a sensor or potentially the output of another simulation. If I start running this, we will start seeing that randomly generated throttle angles start flowing through the stream. There you go. If I head back to Simulink model, you can see that the throttle angle input stream has received and the simulation starts running, where it computes the engine speed as a function of throttle angle and stream that back to an output topic called Simulink output. Now if we head over to our Data Explorer, we can see that our Simulink model of the internal combustion engine is running against live data for throttle angle, computing, engine speed, which is shown by the green light. So that's really all there is to it. It's really easy to deploy MATLAB and Simulink to Quix, which means that it's very easy for you to develop production-ready simulations, digital twins with Quix far more easily. Not only that, all these services and all these streams can interoperate with different runtimes very easily. So which means while your simulation might be running MATLAB and Simulink, you might have applications written in C#, Python, or even Node.js consuming this data, creating dashboards or running other simulations using Quix. So I hope you enjoyed this demonstration. Thank you very much.